Hi class, we're looking at the Mollie and Cassie word problem here. So Mollie at 10 o'clock begins um, to run at an average rate of 10 kilometers per hour. Cassie leaves a half an hour later and starts out on a run along the same route at an average speed of 12 kilometers per hour. How long will it be before the second runner, Cassie, catches up to the first runner? Over what distance will they have traveled and what time will they meet up? So our first question here is our unknowns. And it doesn't matter what you call X. Just make sure you give yourself enough information. So I'm going to let X be Mollie's time. I know her rate, and from her rate and the time, I could always calculate the distance. So while the question asked me how far they both traveled, as far as distance goes, and what time they will meet up, the most important thing is to figure out what that time is. So X is going to be Mollie's time since the rate is in kilometers per hour, I'm going to keep that unit of hours. So knowing that Mollie's time is X, what does that make Cassie's time? Well, Cassie left a half an hour later. So I'm going to, as X minus 1/2. Since Mollie's time may be 5 hours, Cassie's going to be 4.5 hours, and so on. And that's going to be Cassie's time in hours. A lot of you are skipping this step along the way. So please make sure you are identifying your unknowns and being very careful and purposeful in that identification. So I would highly recommend now making a rate table for Mollie and Cassie, in which we place our rate and our time, and what is that going to equal? Distance. Rate times time equals distance. So we know that Mollie's rate is 10 kilometers per hour. Her time is X. Cassie's rate is 12 kilometers per hour, and her time is X minus 1/2. Well, if we multiply rate times time, we get distance, right? Don't forget it is the distributive property here. A lot of people forget that step. What do we know about their distances now? And because we are looking at when Cassie catches up with Mollie, their distances are going to be equal. So I can then write an equation that shows their distances are equal to one another. I can distribute, combine like terms, and solve. And I get X to be 3. 3 what? 3 hours of travel for Mollie. Okay? So then it says, how long will it be before the second runner catches up? So it's going to be 2.5 hours of travel time or running time for Cassie. Okay? Now, if I think about it, Mollie left at 10 o'clock, which means Cassie left at 10:30. If I add 3 hours to Mollie's starting time or 2.5 to Cassie's time, I get what time? I get 1 p.m. because they left at 10 o'clock. So that is the time at which they catch up, time of day. So they will meet at 1 o'clock. And if I go back and look at Mollie's rate, since Mollie traveled 3 hours at 10 kilometers per hour, Mollie covered 30 kilometers, right? Mollie covered 30 kilometers. Well, if you take 12 and multiply it by 2.5, guess what you get? You get 30 kilometers for Cassie. So that is a great check to make sure we did our problem correctly. Okay, hope you like that.